Copying 2D lists. So now we can create 2D lists, get their dimensions, and loop over them. How do we copy them? The first thing we might think to do would be to import copy and to use copy.copy, which appears to work. So let's go ahead and copy this code here, go over here, paste. When we run this, we created a list 1, 2, 3, 4, 5, 6, and then we copied it into the list, and B, sure enough, is 1, 2, 3, 4, 5, 6. So now the problem is if we set A of 0, 0 equal to 42, fine, 4. We'll do 42. I like 42. If we print A, there it is, the 42. But if we print B, aha, that 42 is in B as well. So what we see is that we got a shallow copy, that when we did copy.copy of A, B turned out to hold aliases to these. So let's show you another way that we know that. So print A is B. They're not aliases, but print A of 0 is B of 0, and they in fact are aliases. A of 0 is B of 0. So when we modify A of 0, we modify B of 0. That couldn't at all be what we wanted. In fact, I think it's very unfortunate behavior. I don't believe it should be the default behavior for copy.copy. If you ever wanted it, maybe there'd be something called copy.shallowCopy just for that. But that's not how Python works. So in addition to copy, there's this other notion of deep copy. A deep copy works like a copy, but at each level you get a fresh copy as opposed to aliases. And this small change turns out to be what we needed. So when we run this, again it looks the same. A of 0, 0. We can set equal to 42, and when we print A, sure enough, there it is. But we print B, and no effect, because with deep copy, B of 0 is not an alias to A of 0. And so changes to A of 0, changes to row 0 in A do not affect row 0 of B. So deep copy is the way to go. And you can actually use deep copy on 1D lists just fine. In that case, it's the same as copy for our purposes. We'd rather you just use copy there because it's always best that your code be suggestive of what you really intended. And you intended a 1D copy, as here you want a multi-dimensional copy, hence deep copy. Now, deep copy has a limitation, which is strange, but it's important for you to know in case it rears its ugly head. And this example here shows us what it is. We create a list. And the list is with times. We make it the wrong way. This is a 2D list with shallow copies. So therefore, if we modify A of 0, 0, we modify each of these because each row is an alias to the first row. We've seen this before, nothing new here. The thing is, when you import copy and you copy this list and you deep copy this list and then you modify it, still on the deep copy. See right here, we replaced A with a deep copy of itself. We intended to make each row distinct there. It didn't work. What came out still produced 42s in each case. And the reason is deep copy will preserve aliases. So right here we have aliases in A. And when we deep copy, what comes out has aliases as well. So if you wanted to get rid of aliases and have a genuine copy of everything, we've provided that here with this my deep copy. It's recursive, it calls itself. Therefore, you are not accountable for how this works. You will be in a few weeks when we cover recursion. For now, just understand that this is a function that takes a list and copies it such that even aliases come out as copies. So here, when we modify A of 0, 0, it only modifies A of 0, 0, and the other rows are not aliases. Sure enough, when we run this, we can see the effects are exactly as stated. It would be rare for you to need my deep copy because creating aliases in 2D lists is so frowned upon that we would want you to strongly avoid the situation in the first place rather than to use this as a way out of it. But if someone gave you such a 2D list and you wanted to rid yourself of the aliases, this would be a way to do it. More generally, just create 2D lists without aliases and use copy.deepcopy to copy them.